Assalamu alaikum guys, how are you doing? I hope you are doing good, staying home and staying safe. Alhamdulillah. Welcome to e-learning. This is the file that I posted on Moodle and shared you on WhatsApp group as well. So let me go through it. This is what we did in our last lecture before the suspension. If you remember, we were discussing discrete random variables. So here I wrote some notes and posted on Moodle. So let's go through and see how can I explain. So the topic is discrete random variables. Okay. So any variable that is associated to a random experiment, or you can say that any variable that is determined by the outcome of a random experiment. If you recall, we define random experiment to be any experiment whose outcome cannot be predicted. We know all possible outcomes, but in a certain trial, we cannot say what will be the outcome right now. For example, if I toss a coin, I know there are possibilities of head and tail, but if the coin is in the air, I cannot tell you what will be the outcome for this trial, or I cannot predict the outcome, whether it will be head or it will be tail. Similarly, if I roll a die, I know all possibilities are 1, 2, 3, 4, 5, 6, but in a certain roll, when I throw a die, I cannot tell you that what will be the outcome, or I cannot predict the outcome, right? So these are the examples of a random variable. So here the example is very simple, this one. For example, if we toss 3 coins together and let x denote the number of heads, then the random variable x consists of the values 0, 1, 2 and 3. Why? Because when 3 coins are tossed, there can be at most 3 heads. There cannot be 4 heads on 3 tosses of coins, right? And at the minimum, at least there should be 0 head. If all of them, all the tails, then no heads appear, right? So either it will be 0 head, all 3 tails, 1 head, 2 tails, 2 heads, 1 tail, or 3 heads. Because we are saying that x is the number of heads, so I'm not telling you anything about tails. When I say x is equal to 0, it means 0 head. So it automatically means that there are 3 tails. Okay. So in this example, x is a discrete random variable. What is a discrete random variable? A discrete random variable is a random variable that can assume finite or countably infinite values. So basically 1, 2, 3, 4, 5, 6, these are finite values, right? Or you can go to infinity as well. Like 1, 2, 3, 4, 5, 6 can go to infinity, but we call it countably infinite. We can count the outcomes. Okay, these are the discrete random variables. So let's now discuss the concept of discrete probability distribution. If I write down the outcomes or the values of a random variable x, for example, in this above example, we have the value 0, 1, 2, 3, right? And if I write the probabilities of 0, 1, 2, and 3 with it, then it will be a probability distribution. I did this example in the class. If you look at the lectures which I did, you can recall this probability distribution. But anyway, let me go to the next example which is written here. If a biologist let me use the same highlighter. So if a biologist is interested in the number of petals on a particular flower, this may take the values 3, 4, 5, 6, 7, 8, 9. Now this is given to us. We don't know what is this, because a biologist is interested in the flowers, and you know that every flower has some petals on it, right? So he said the flowers we are considering, they can have 3 petals, 4, 5, 6, up to 9 petals. So there, all these flowers have at least 3 petals and at most 9 petals, and each one of these member will have its own probability. Of course, every 2, 3, 4, 5, not 2, 3, 4, 5, 6, up to 9, they will have its own probability as well. So let's say he gave you the number, he give you the division of these flowers as well. Suppose that upon observing a large number of flowers, say 1000 flowers, so that biologist observed 1000 flowers and he gave you the frequencies, right? So what are the results? The following results are obtained. So here he gave you the values, you see, x can be 3, 4, 5, 6, 7, 8, 9. Now these frequencies are given to me. He said, see, f is the frequency. So he said the flowers out of 1000 flowers, 50 flowers had 3 petals, right? Similarly, 100 flowers had 4 petals, 200 flowers have 5 petals, 300 flowers have 6 petals, 250 has 7, 75 has 8, and 25 has 9 petals. So if I add them all, if I add these all, you have 1000 flowers. Of course, we are dealing with 1000 flowers. Do you see here? 1000 flowers. So I have to have all of them back here. Now you remember that we had a relative frequency. We studied relative frequencies at the beginning. If I divide all these frequencies by the total frequency 1000, I will get relative frequency. So this is the formula, you see, f divided by summation f. So every frequency can be divided by 1000, and this relative frequency can also be treated as probability. You remember we discussed 3 types of probability: classical approach, subjective approach, and relative frequency approach. So this is the relative frequency approach. So you see, I divided 50 by 1000, I divided 10 by 1000, 200 by 1000, 300 by 1000, and so on. So you see, these are my relative frequencies. So these are relative frequencies which I got, and sees the sum of these relative frequencies is 1. So we can call it P of x, the probability of x. So this is the value of x. X1 is 3 and probability of x1 is 0.05. This one. Similarly, if x1 is 6, then probability of 6 is 0.30, and so on. Okay. So this table is called the probability distribution. So this table is called the probability distribution. All right. Or in particular, we can say discrete probability distribution, because my random variable was discrete. So there are 2 properties related to discrete random variables. These are the 2 properties. The first property is all the probabilities will lie between 0 and 1. You already know that the probabilities are always between 0 and 1. And second property is that if I take the sum of all probabilities, it is 1. So summation of pxi means the total probability is always 1. So these are the 2 properties of discrete probability distribution. In the previous example, since the number of petals on a leaf can only be whole number, hence the variable x is known as a discrete random variable, and the probability distribution of this random variable is known as discrete probability distribution. All right. So in other words, what I can say, that any discrete variable that is associated with the random experiment and attached to whose various values are the various probabilities, such that your px, the sum of all probabilities, is 1, is known as the discrete random variable, and its probability distribution is called discrete probability distribution. So this is more precise definition basically. So these both paragraphs, the above and the below, they are the same, but in the down one, in this one, we give you more rigorous definition of discrete variable and discrete probability distribution. Just in the case of his frequency distributions, you remember, if you recall, when we had x or groups and along with the probability is given, frequency is given, we called it frequency distribution, right? So, and you know that we draw the graphs of frequency distribution, which was called histogram. Okay, so now the graph of this discrete probability distribution is called line chart or bar chart. It's similar to the histogram, but we do not call it histogram, we call it bar chart. So let me show what is that. So if you look at this distribution, you can see that the values of x are given on this left column and probabilities are given on the right column. So if I write this x on the horizontal axis here, on the horizontal axis, and if I write here on horizontal axis, we can give the values of x. X can be 3, 4, 5, 6, 7, 8, 9, and these are the probabilities. You see, 0.05, 0.1, 0.15, 0.3, because here the highest probability was 0.30 here. That's why I picked this topmost point as 0.30, right? So now you see the 3 had probability 0.5, you see, 0.5. 4 had probability 0.10, like here, right? Similarly 0.15. Third one was 0.20, so you see here I got 0.20. Then 0.25 and 0.30 was the maximum for x is equal to 6. So these are not aligned here. I think when I created a PDF, they went to a little left. So this first bar below that should be 3 here, 5 here. Okay, let me try to write it. Maybe I may be able to write it here. Anyway, this is your 3. Okay, this is 3. So writing with the mouse is not easy. So this is your 4. Okay, and this is your 5. Okay, pardon my writing here. This is my 6. Okay, and so on. Okay, so you can adjust it, or maybe I will try to fix it up. And so here it is 8 and this one is 9. Okay. So this is called line chart or bar chart. Both names are given. Some people call it probability histogram as well, because it is very similar to the histogram. So if you call it probability histogram, it will not be wrong. But usually we do not assign histogram, this name, to the probability chart. We call it bar chart because you see there are small bars along with any. So bars give you the probability against every variable. Okay. As was the case with the frequency distribution, we find center and spread as well. What were the center? Measure of central tendency, mean, median, mode, right? And in measure of dispersion, spread was variance, standard deviation, range, interquartile range, interfractile range. These all things were there. But good news for the probability distribution is that for measure of center, we only calculate the mean. And for measure of spread, we only calculate the standard deviation or variance. Variance and standard deviation are the same. Only square root difference is there. So only mean and variance, or mean and standard deviation. So only two things in probability distribution. So mean is very easy. You know that what was the mean? If you recall, the mean was summation x f divided by summation f. If I replace frequency with the probability in the formula here, if I replace the frequency with the probability, let me highlight it. This was f in my old formula, but now it is p. And you know that summation of p is equal to 1, right? So my formula becomes very, very simple. Only summation x px. So if x is given and the probabilities are given, what we will do, we will just multiply these two. We will just multiply these two and write it here, x px. So if I multiply 3 with 10, 3 with 0.5, 4 with 10, 5 with 0.20 and so on. For example, this is 6 with 0.3 gives me 1.8, right? And just take the sum. If you just take the sum here, This is the total sum, and this sum is your mean. That's it. 5.925. Okay. Let me bring it down. So this is your probability, you see. Hence your mean is, you see, mu is equal to summation x px. This is the simple formula, and your mean becomes 5.925. Okay. This is also called the expected value, because this is what we expect on average. On average, we expect this one. You see, this was the petal problem. We say that a flower can have 3 petals, 4 petals, up to 9 petals, right? So we can say that if we collect flowers from that garden, on average one flower will have almost 6 petals on average. We know that there are some flowers with 3 petals, some with 9 as well, but the average number what we can expect from this batch of flowers is that it may have on average 6 petals. So this is called the expected value, because the probability is associated with it. So we expect something here, right? Whenever there is a probability, we expect something. So this is also called expectation, and we usually denote it by EX. So expected value of X, or we simply say that expectation of X. EX means expected value of X. So mu is EX basically in probability distribution. Okay. So basically what we mean that given the probability that flower has 3 petals is 5%, the probability that the flower has 4 petals is 10%, and so on. This is the table. We expect that on average a flower contains 5.925 petals. 5.925 petals cannot occur, of course, either it will have 5 petals or 6 petals. So this is close to 6, so we can say that on average we can expect 6 petals. Now going to standard deviation. Again, the formula is very similar to frequency distribution case. So here it is. You see, sigma standard deviation is equal to, you remember this was in the frequency distribution, this was the formula, but when we simplify we use this formula, right? Summation fx square over n was summation f, so summation f for n, anything can be used, minus summation fx by summation x square. This was the formula for population standard deviation. Okay, so similarly in case of probability distribution, what we will do, we will replace this f by p. You see, this f is replaced by p here. You see, in this formula f is replaced by p everywhere. F is replaced by p, and we know that summation px is 1. This summation px is 1, so it means we don't have to divide. I can just write simply summation x square px minus summation x px whole square. So this is your and you see, this is the mean. This is basically the mean. This one, this is mu, right? Or maybe I can use a different pen. This one here, this one is mu, the mean, the expected value of X. Okay, and you remember we had mean in the standard deviation formula as well. So going back to the previous example, if I have to calculate the standard deviation, what I can do, I will make one more column. You see, I need summation x px and I need summation x square px. You see in the formula, so I will multiply this x px one more time with x. If I multiply x px one more time with x, so you see 15 times 3 is 45, so you got 0.45. 1 into 5 is 5, right? Similarly, 0.6 with 8 is 4.8, right? So if I multiply and add them up, this is summation x square px. This is summation x px. So if I subtract, you see summation x square px is 36, so I got it here. This is summation x square px, and this is summation x px whole square. So after simplifying, I will get this answer. So my standard deviation is 1.3. 1.3 means this is the spread of the data. Okay, spread of the data. So you see here I fixed it. You see 3, 4, 5, 6, 7, 8. So they are in the right place. So this is the same graphical distribution. So you see mean is in the middle here. You see 6. 6 is the mean, which is almost in the middle because this is the center, right? And spread is the variance, that how far this is 1 unit away. So I can say that if I pick this value, this value is 1 standard deviation away from the mean. If I pick this value, this is 2 standard deviation away from the mean. Similarly on the left side as well, if I go on the left, this is 1 standard deviation away from the mean, and so on. Okay, so standard deviation is sometimes used as a scale. So this was mean and standard deviation. So now we have both mean and the standard deviation. So what we can do is we can calculate the coefficient of variation. We calculated it over there as well in frequency distribution as well. What is coefficient of variation? CV, coefficient of variation. We divide the standard deviation by mu and then write it as a percentage, multiply by 100. So 1.3 is sigma divided by mean 5.925, and if I multiply with 100, it will give me 21.9%. This is the coefficient of variation. Standard deviation as compared to the mean. 1.3 is standard deviation, but if I compare 1.3 with the mean, this is 21% of the mean basically. So very less, right? Very less than that. If it is 100%, if your coefficient of variation is 100%, it means mean and standard deviation are the same. Standard deviation is the same as the mean. If it is 50%, it means standard deviation is half of the mean. If it is 200%, it means standard deviation is double than the mean. Okay, so coefficient of variation, compare your spread with the mean, compare your spread with the center, compare your standard deviation with the mean. So this is another example which is very simple and straightforward example. If I roll 2 dice, right, and say that I can call some random variable here. You see, this is very similar. This question is very similar to what I asked in the midterm. If 2 fair dice are thrown, here he asks you what is the probability distribution of the sum of dots on 2 fair dice. You remember when we roll 2 dice, this is my sample space, right? This is the sample space. 1 with 1, 1 with 2, 1 with 3, 2 with 1, 2 with 2, 2 with 3, and so on, right? So from 1 1 to 1 6, all of them. So if we can write sum as well. Instead of writing 1 1, I can write 2 here, I can write 3 here, I can write 4. Why? Because we are interested in the sum here. You see, we are interested in the sum on 2 dice, this one. Okay, so now if I want to write, you see, no random variable is given in my question, but they only said the sum. So what I will do, I will define random variable on my own. So I can say that let x be the random variable representing the sum of dots which appear on the dice. Then your x can have the values from 2 to 12, because the minimum sum, the first one here, is 2, and the maximum sum can be 12. This one, this can be 12. So your minimum sum can be 2 and the maximum can be 12. So your values will go from 2 to 12. Now if I want to find the probabilities of all of them, you can easily find the probabilities. How many 2's are there? How many 2's are there? Only 1 2. So 1 by 36. 3's are 2. See, 1 2 and 2 1. Let me erase this highlighter, and now I can go back. You see, if I want to find what is the probability of 3, you see there are 2 3's. This is 3, 1 2 and 2 1. So it means the probability should be 2 by 36. So you see here the probability is 2 by 36. Okay, similarly you can go on, find the probability of 3, 4, 5, 6, 7, 8 and up to 12. What is happening here? Let me figure it out. Here you go. So now we calculated all the probabilities and we can write this in a table. So if I write this in a table here, I wrote the values xi from 2 to 12 and then the probabilities which I calculated from 2 to 12. So this is the probability distribution which gives you the sum on two dice. Sum on two dice. Okay, and this is also a discrete random variable because the random variable, you see, from 2 to 12 it's finite and have integer values, so it is a discrete random variable. So I am stopping here. After that we had a concept of, or maybe let me complete this example. This is not completed. So if I go back, there was a second question as well. Second question is this one. Use the probability distribution to find the probabilities of obtaining a sum that is greater than 8 and then the sum that is greater than 5 but less than or equal to 10. So now I can answer these questions from the probability distribution. For example, if you want to answer the first question, which was what is the probability that the sum is greater than 8? So you see, you can add these values. So let me erase this highlighter. So I'm erasing this and now I will redo it because now I am interested in the sum greater than 8. Sum greater than 8 means from 9 to 12. So 9, 10, 11, 12. So if I add these four values, this will be the probability. So from here you see probability of x greater than 8 means 9, 10, 11, 12, right? So I can add the probability of 9, probability of 10, probability of 11, probability of 12. So if I add them, I got 10 by 36. So this is the probability that the sum is greater than 8. Similarly, I can find the probabilities of the sum greater than 5 but less than 10. The second part was, what is the probability that the sum is greater than 5 but less than 10. So greater than 5 and less than 10. So it means I am between 5 and 10. So 6, 7 and 8, only 9. You see, 5 is not included. Why 5 is not included? Because he said greater than 5. So greater than 5 means 6, 7, 8. But less than or equal to 10. Here you see less than or equal to 10. So we are from 6 to 10. So if I add the properties from 6, 7, 8, 9, 10, I got this answer. Okay. So this is the the second part of the question. Yeah, so next concept is a distribution function, and let me finish this video here because it's already 29 minutes. So let me make another video for that. So this is your discrete probability distribution and discrete random variable. Okay, we will have continuous random variables as well, but so far we studied about discrete random variables and its probability distribution, how to find the mean and variance of these distributions. So the next concept is distribution function, and I will make a separate video for that. See you soon. Hope you like it.